Let's do an experiment. Let's go to a grade 1 classroom and weigh all the students and find out the average weight of these grade 1 students. If we found that 50% of the students weighed exactly 50 pounds and the other 50% of the students weighed exactly 100 pounds, what would the average weight of the grade 1 students be? Well, we're really just taking the average of two numbers. So we can take 50 plus 100 and divide by 2. And we end up with 75 pounds. You may have even been able to do this one in your head. Let's try another one. This time we'll go down to a grade 2 classroom. And this time we found that 20% of the students weighed 50 pounds and the other 80% of the students weighed 100 pounds. What would the average weight of a grade 2 student be then? Since it's not split 50-50, we can't simply add these two numbers together and divide by 2. So one way we could solve this problem is take 20% of 50 by multiplying 50 pounds by 20%. Now anytime we're multiplying a number by a percentage like this, we're really just multiplying the number by the decimal form of that percentage. So in other words, we're multiplying 50 by 0.2 and we get 10 pounds. We can add this to 80% of 100 pounds, which is 80 pounds. And so when we add these two numbers together, we end up with 90 pounds. And so the average weight of our grade 2 students is 90 pounds. Just like our grade 1 and grade 2 students have different weights, the atoms of an element usually have one or two different masses. We call these isotopes. Isotopes are atoms of an element with the same number of protons but a different number of neutrons. Remember that what makes one element different from another element is the number of protons. And remember that neutrons are a neutral particle with the same mass as a proton. Let's look at hydrogen as an example. Hydrogen actually has 3 isotopes. Well, there are actually more, but 3 stable isotopes. We have hydrogen, or protium, which is the first one here. We have deuterium, and then we have tritium over here. Now, what's the same about each one of these isotopes? Well, we can see that each isotope has only one proton. Now, what's different is the fact that each isotope has a different number of neutrons. Remember, it's the protons that give identity to the element, and so hydrogen must have one proton. The number of neutrons don't give identity to the atom. Remember that scientists gave a special unit to describe the mass of a proton and a neutron? We call that the atomic mass unit. And remember that protons and neutrons have the exact same mass, which is 1 AMU, or atomic mass unit. If we add up the masses of each of these isotopes, we could see that they are different. Hydrogen, or protium, has a mass of 1 AMU, whereas deuterium has a mass of 2 AMU, and tritium has a mass of 3 AMU. Each of these are still hydrogen, but they have a different mass because the number of neutrons has changed. As with our examples of the grade 1 and grade 2 students, scientists are interested in finding the percent abundance of each of the naturally occurring isotopes. And once they have found those percents, they can calculate the average mass of that element. For hydrogen, 99.98% of all naturally occurring hydrogen is protium. 0.02% is made up of deuterium. A very, very small percent is made up of tritium, and so it's basically 0. When scientists take the average of these isotopes, they find that the average mass for hydrogen is 1.00794 AMU. We actually give this a specific name, and you'll see this number on the periodic table. Go ahead and look at hydrogen on the periodic table, and in that square you should see this number. This number is called the atomic mass, or the atomic weight. The atomic mass of an element is the weighted average mass of the atoms, or isotopes, in a naturally occurring sample of the element. Let's try to solve an example of a problem that you might find in chemistry class. Carbon has two naturally occurring stable isotopes. 99% is carbon-12, which has a mass of 12 AMU, and 1% of the carbon is carbon-13. What is the atomic mass of carbon? We can solve this problem in the same way we solve the problem with the grade 1 students and grade 2 students. We can take 99% of 12 AMU and add that to 1% of 13 AMU. And our answer is 12.01 AMU. Check your periodic table and you'll see that's the atomic mass for carbon.